Thank you. Good afternoon, everybody. Welcome to our webinar, which is on the electrification of coffee roasting, run by BCA. So my name's Paul Rook. I'm the Exec Director at British Coffee Association. We've got a couple of presenters this afternoon. You'll see Ben starts from Bellwether Coffee, and then Gert from Ray Jules will give the second presentation. We're hoping to allow about 20 minutes or so for questions. We've got quite a number of questions that you've submitted beforehand. We've actually sort of given a flavour of those to both presenters, so they may pick some of those up as we go through, because there's been one or two sort of themes running through. But if you've got other questions that come up as we go through the presentations, drop them into the chat. You'll see the chat function as normal at the top of the screen. If you can keep your microphones and your cameras off during the presentations, that would be great. And for those of you that want to just go back and pick up parts of the presentations again at a later date, a reminder that we will be editing this and dropping it into our BCA website at www.britishcoffeeassociation.org. If you go into public webinars, you'll find about a dozen or so webinars there, and this will be added within the next day or so. So without further ado, enough from me, and I'll hand over to our first presenter, who's Ben Ireland from Bellwether Coffee. Ben, it's all yours. Thank you.
Yeah, thanks, Paul. Hi, everyone. Good afternoon. I'm pleased to be here with you all. And I'm going to share a quick introduction to Bellwether, our roasting system, and a few examples of some customers that we have around the world. I joined Bellwether last summer to support our launch into the European market from my base in the UK. Bellwether is based in Berkeley, California, and we were founded 10 years ago. We were built on the idea that anyone who serves coffee should be able to roast their own coffee and to do it sustainably. And this led to the development of our electric, automatic, ventless roaster for in-store decentralized roasting, and to help move the coffee industry away from its reliance on fossil fuels. I am going to start with the story of one of our first customers here in the UK for an example of what we believe the electrification movement enables. And this is High Grade Coffee. They are a single site, independent specialty coffee shop on Brick Lane in East London. And it's owned and operated by Liam and Stevie in the picture here. They have ambition to scale their business, and they've always wanted to roast themselves for the control and the quality and the lower cost that this can bring with it. But they've got really limited space, tiny site, and they're in a listed building that wouldn't allow for any kind of ventilation. They installed their Bellwether roaster late last year and began roasting firstly for the cafe itself, for the bar. And that's about 50 kilos a week. It's a busy cafe. But then they also launched their own brand of retail coffee, selling in-store and online, and also sell wholesale to offices and cafes around their neighborhood, and now roasting around 200 kilos a week. They've significantly increased their revenue, increased their operating margin, and done it without any increase to their overhead. And I think what's interesting about them is originally their plan would have been to grow the number of cafes 2, 3, 4, 5 before then opening a roastery and roasting for themselves. But this has flipped their model on its head, and it's now built around a cafe roastery site. So their plan is to replicate this model and to serve other neighborhoods with a more distinctive brand, diversified revenue, more profitable, and they're doing it on a more sustainable model than the traditional one. So yeah, wanted to start with that as a pretext to Bellwether, the technology, and as an example of what it can do. So Bellwether, the Bellwether roasting system, it comprises the roaster itself, our cloud-based software for managing and editing digital roast profiles called Bellwether Roast Manager, and our green coffee marketplace with a selection of coffees sourced under our impact programs. The Bellwether roasters, so the one on the left, I hope that's the left on the screen as you're seeing it, but the roaster on the left is our Series 2 roaster, and this has been on the market since 2018. It's our second generation roaster with a 3 kilo capacity, and we have about 300 customers using this roaster across North America. But we launched the roaster on the right which is the Bellwether shop roaster, in March this year. And the first of these are going to be installed into the UK later this year. The shop roaster is a small format, high throughput roaster. So it comes in two configurations: the countertop, the one on the furthest right, with a 1.5 kilo capacity, and then the optional continuous roasting upgrade that will roast on loop automatically. So to operate the roaster, users will load green coffee into the hopper, either a single batch on the countertop version or up to 20 kilos into the continuous roasting hopper, and then select number of roasts to run. They'll then select a roast profile on the screen and press go. The roaster will automatically preheat, load the coffee, roast and cool. And it takes less than 2 minutes for a single batch, or around 20 minutes to then complete a roast cycle. And roast profiles, digital roast profiles, are created by our coffee team, can be downloaded for the coffees that come from our marketplace, or they can be created by the user for their own coffees that they're sourcing. And then anyone can operate the roaster. So you don't need experience of roasting once the roast profiles are created and loaded onto the machine, and roast profiles will just be displayed on the screen to select. It is a drum roaster. It's heated with air. So it's a combination of convection, conduction roasting, but it's predominantly conduction. And so being a drum roaster will still roast to a comparable style and quality of a traditional drum roaster. But it uses a closed loop system, which minimizes the energy consumption and helps with consistency, or ensures consistency between roasters, and then importantly, roast to roast as well. I mentioned they're ventless. So these are ventless roasters. This is achieved by recirculating the air, passing it through carbon and HEPA filters. So the air that is exhausted is clean and ultimately just emits a small aroma. It's electric, of course, and requires just single phase 32 amp power supply and a Wi-Fi connection. So these features ultimately mean it can be installed anywhere without the need for venting, and then the regulations, restrictions, and that are increasingly coming with this. I think particularly helpful here in Europe compared to the US, where our buildings are a lot smaller, older, and maybe our planning laws are a little more restrictive. But beyond that, roasting your own brand of coffee is creating genuine differentiation in an increasingly crowded marketplace, but also for owners, more control of their coffee offering, their quality and the freshness. And then I mentioned the savings, purchasing green coffee over wholesale, 30 to 50% saving, additional revenue streams from selling retail, online, wholesale. These are real improvements in profitability. So as an example, a retailer, cafe, any retailer really, using 50 kilos of roasted coffee a week can pay back the purchase of a roaster in less than 6 months. And if it's financed, it will be cash flow positive from day one. Now, the impact of that ventless electric on-site roasting results in reduced carbon emissions from our third-party study, 87% versus a traditional centralized gas roaster. The majority of these savings are achieved from from electric versus gas, and then even more so if electricity is generated from renewable sources, but also from being localized roasting, reduced transportation and packaging costs. So I mentioned high grade as an example, fairly typical customer story, but the use cases for Bellwether are really varied. And so for some quick other examples that might resonate with some of your businesses as well, Muji, the global retailer, they installed a Bellwether in their flagship store in Tokyo, roasting all of their coffee for an on-site cafe and retail sales, and now rolling this out to other stores across Japan. Bon Appetit, part of the Compass Group, they're using 2 roasters in their commissary kitchens to serve offices throughout the Bay Area in San Francisco, and they're roasting over 200 kilos per week for custom coffees for each of their clients. Starbucks, in their reserve store in Bali, has a Bellwether installed where as part of a kind of seed to cup concept within the store, but roast profiles are created, curated, QC'd and managed in their US headquarters and transferred over to the other side of the world. And then finally, for an example of Bellwether used at scale in what would have previously been a traditional roastery with gas roasting operation, Heirloom Coffee Roasters in California have 18 Bellwether Series 2 roasters as part of a switch to electric. So yeah, here in Europe, feels that we're really just getting started, but we're working with a real broad range of customers who have been pre-ordered their Bellwether shop roaster to arrive later this year. This is everyone from specialty coffee, small independent coffee shops, specialty coffee shops, through to cafe chains, to established roasters, and then even on the other end, individuals starting up a whole new business built around Bellwether roasters. So yes, I'll finish by saying, watch this space. Roasters will start to get installed, and I'd really encourage you to get out to visit these businesses, taste the coffee for yourself. I think that's the best proof of quality we can offer. And then, learn more about these business owners' motivations and the impact of roasting on electric for themselves. So I'll leave it there. Looking forward to answering any questions, and of course, happy to speak to anyone about Bellwether, any of these topics today or another time. So thank you for your time.
Thank you, Ben. Just a quick reminder from me to people, yes, to drop your questions into the chat function. We'll pick them up at the end. So we'll now move on to our second presentation, which is from Gert. So Gert, over to you. If you can bring your screen up, please.
Hello, everybody. Does anybody in the room here know what this is here on the screen? Well, in fact, it's something famous. It's the first automobile patented by Mercedes-Benz, Carl Benz, in 1880, so end of 19th century. And in fact, coincidentally, it's the same year as industrial batch coffee roasting was invented. So it's nice to know how long we're already going along with the current technologies. My name is Gert Linthout. I work in several companies around sustainability. I founded Micmac Minuscule together with my wife on second-hand birth lists. I'm a partner at Ray Jules Coffee, and I'm also lead for coffee roasting at CE Cleantech, which is the sister company of Ray and Jules. If we look at the challenges and the opportunities for the future, then I don't think that I'm telling a lot of surprises here by saying that climate change is accelerating and specifically for our sector also threatening coffee production. And so that's specific to our sector, that in fact everybody realized that if we want to be producing coffee, then the plantations should be saved. Second thing, which is positive or an opportunity rather, is the fact that more and more studies prove that consumers care about sustainability and want to pay for it. And then thirdly, and which is also an opportunity, I think, is that we still today on industrial scale roast with technology which is 100 to 150 years old, and fossil fuel is still the norm on the one hand side. On the other hand side, if you compare the technology we're using in food industry broader, but certainly in coffee roasting, then there is a lot of room for improvement on entering the smart age, on the digital age. If you look at benchmarks on that point, out of the 10 most prominent sectors worldwide, food is number 9. So there is a lot to be learned from other sectors, also from heavy industry like chemical industry, for instance, which is moving much faster than food industry. We are very happy to see that a lot of companies, global and local, are stepping up, and they know this, they understand this, and they want to take the lead. And that's something that we have seen changing in the last 5 years. Before, we typically saw questions relating to clean technology related to cost. Cost is always important, of course, but now we see that the market is driving the fact that sustainability is getting more and more important. So it's market driven, which is typically the fastest way to innovation. And if you would ask us, those are the 4 topics that we need to tackle, or 4 important topics that we need to tackle for coffee roasting. That's 1, how to move away from fossil fuel. And this links to the next 2, which is an increase in energy efficiency on the one hand side, and also how we can connect industrial scale roasting to the grid or to other ways of renewable energy, because the current way of batch roasting puts specific struggles there, and we will address this later on. And then a last one is also, can we move coffee roasting into the smart age? Because we know that there is a lot of data could be available, but typically coffee roasters are still, compared to other industries 50, 60 years ago, we haven't moved beyond the 2.0, let's say. So that's what we were thinking about. We in our clean tech company, this is Koen, our CEO, he was thinking about how can we move for conservative sectors like food, how can we move forward now? And for this, it's, I think, important to briefly explain who we are. At the start, 2007, Koen founded CEE, the clean tech company, with one goal, that's to help industrial players which have a large energy demand to move away from fossil fuel. That's what we have been doing since 2007 for more than 200 industrial groups worldwide. A bit later, we also founded our non-profit organization where we help people in the south, small hospitals and schools, to have stable and clean energy supplies. And it are the engineers of CEE who also do this voluntary next to their jobs. And then 2017, working a lot for food and having had the feeling that we needed acceleration, we founded our own coffee company to prove that another way of roasting is possible without fossil fuels. So we founded, as a clean tech company, a sister company, which is Ray Jules, the sunny kind of coffee, voila, which is also the first pioneer having used the technology we're talking about. CE is there to get energy intensive industries to help them in their journey to net zero with specific clean tech expertise, which mainly around thermal processes, end to end. So from idea to realization, and even financing is what we do. And we help speed up the transition by financing the clean tech we build to make sure that certainly if it's new technology, that part of the risk and part of the capex risk can be taken away. We have done this for more than 200 groups, as I already explained, and in fact 2 to 3 domains: roasting, what we're talking about today, drying, think of drying of malt, for instance, and new technology development, so from scratch. An example, we just built a factory for CO2 absorbing bricks in the construction materials sector, which was a technology that was thought about since decades but never been realized on large scale, and that this is what happened last year. And those are the sectors we work at most, and where we are different with almost all providers of roasting technology is that we don't come specifically from the coffee sector itself. We have learned the job, we have learned to optimize across sectors, and we take that input to try to do disruptive changes within sectors like food. And interestingly, food is one of the last sectors where batch processes are still the norm. So this is interesting to think about. For coffee specifically, in 2017, we founded our own coffee company. Why? We had been working for one of the largest roasters worldwide. Question on improving energy efficiency. We came with the idea to go fundamentally from a batch to a continuous process, electrification, but we were too early, 2013. We tried for some years, didn't work out. So we started our own coffee company to prove that it's possible, and also to fine-tune the technology, which took us 2 years before we entered the market, end of 2019, just before the COVID crisis. In the years after, we focused on our growth and international exposure, and also in the fine-tuning of our recipes, our quality, and so on. By now, we have more than 30,000 customers, coffee customers who drink our coffee every day, and we are mainly focused on the fresh coffee at home and in offices. That's our market, mainly in the Benelux. Big step last year where Sucafina subsidiary Bayers Coffee announced to build a full-scale industrial full electric line of 20,000 metric tons per year, so 45 million pounds per year. and this has gained us a lot of speed. We also had the chance or the luck that some people from the coffee sector joined our ranks. For instance, Hans Melot, which was one of the former executives of Starbucks, has joined our board. Stéphane Glorieux of Keurig Dr. Pepper in America. So we have been strengthening the organization to make sure that Europe and North America, which is our prime focus domains, that we can serve those markets. And then finally, a bit earlier this year, we expanded our pilot roastery of 2019 to a 15 times larger roastery to fuel our own growth, also subsidiaries outside of Belgium, and also to accelerate industrial trials. And we are quite proud to be able to say that today 60% of the top 10 coffee roasters have engaged in this process. So we're finally at the point where we want to be, that's accelerating that change, that snowball effect, where we feel that the sector standard can move away from fossil fuel, from batch roasting, to an alternative one with clean energy. A quick explanation on the coffee roasting technology itself. Why did we choose, or why do we think that a continuous process is a good idea? If you look at batch roasting, it has certain characteristics, but some are not ideal in the move away of fossil fuel. Why? In a batch process, you have typically an energy demand which has peaks and then the lower ones, whereas a continuous process has a flat consumption. On the other hand side, traditionally, certainly drum roasters mainly relied on a way of heat transfer with very high air temperatures, while in a coffee bean, you only need between 200 to 230 degrees, let's say. There are much more efficient ways to transfer heat in a much more precise way. In the technology that we build, we can rely on air, which is only a few degrees higher than the temperature inside the beans, which gives us extreme precision in roasting, and which is much more energy efficient than the traditional drum roasters. As a consequence, full electric roasting is, between brackets, quite easy because it doesn't consume too much energy and the consumption is flat. As a consequence, we can eliminate fossil fuel. And a last one, which we realized only during operation, is that due to the fact that we built the technology in such a way that it's much more safe, it's also easier to move to unmanned operation. It's something that we did from day one. We leave our roaster unmanned during the night, for instance. Why? Because it has been built in such a way that it's always monitored, that there are much less risks in terms of temperature and so on. So also safety is a benefit, which we didn't envision at start, but what we saw during operation ourselves last 6 years. This is the technology. What you see here is a roaster which roasts horizontally, which means that coffee beans are transported through different zones on a perforated belt. And in those different zones, we can apply specific temperatures, air speeds, air directions. And it's during those different zones that we are able to create the recipe. So in fact, and that's how we build it, we build technology around the coffee bean. So you could say, except for the fact that the beans are not moved vigorously like in a traditional system, that the bean, from a temperature point of view, doesn't know she's in another roaster, which we did on purpose, of course, because we want to create that flavor profile as you do in traditional roasters, but without the drawbacks of the technology. Of course, if you have a continuous system, it's much easier to recuperate air at the end and to preheat, which also means that we don't need water to cool down the beans. We just cool down with air. We can foresee quenching, but we don't need it, which also means that that we have no need for afterburners, because the temperature is much lower than of the air is much lower than a traditional system, and it's a continuous flow, and we don't have those peaks of the quenching of the coffee beans. Dehulling, we only do afterwards, after the beans have left the roaster in the cold stage, which also adds up to the safety aspect. From a benefit perspective, what does this mean? That if you have those more intimate relation between air and bean, that means much higher precision, up to degrees inside the bean. We measured inside the bean to know how that relation is. And secondly, we also see positive tests on reduced material loss. Secondly, if you look at efficiency, if you look at a traditional batch roaster with a typical peak in the beginning in energy consumption, you have a stable consumption of energy, which is of course a huge benefit when you want to connect to the grid. And same goes for odor treatment. In a traditional pattern, you would have energy consumption like this and an odor peak like this. In a continuous system, they're both flat, which also means that what you need in terms of odor treatment is also, you can design it on the average, not on the peak. In our specific case, this also means that an afterburner is not needed. Just we use active coal in our current system. Why? Because the temperature of air we have to treat and the volume is much lower than in a traditional system. As a result, it's quite logic that the connection to the grid is much easier. And then from a safety perspective, to make it more intuitive, if you look at the reasons why the system is more safe, then it's because the maximum air temperature is lower than in a traditional system. It doesn't have to be much higher than, let's say, 10 degrees higher than the hottest temperature inside the bean. And the number of beans in the hottest zone is also much lower, which means that the thermal between bracket mass that we have in the danger zone is much lower, which also means that the means to protect the machine and the sensoring can be limited to several zones, not to the whole batch as in a traditional system. Which capacity range do we cover? We have today three for the 150 to 500 kilogram an hour. The Caldi, the Zephyr is the medium size 500 to 1500 kilogram an hour, and the large one, the Sherpa, goes up to 4000 kilograms an hour, which means that we cover the range of small to large scale industrial roasting. We won't go below the 150 kilogram. Why? Due to economic reasons, but also due to technical limits of the technology. If you look at near future, when you look at continuous technology, which is the norm in most other industries, you can expect quite soon that quality monitoring steering will be done continuously and real time. If you link this to advanced sensing and AI, it's not so difficult to imagine that in future optimization of recipes in terms of energy consumption, but also flavor profiles will be helped by artificial intelligence, certainly because you can sense everything in our system, as well on the bean temperature, as well on the atmosphere in each different zone. So as well chemical composition, temperature, and so on. Potential health benefits have been suggested. We're looking into this with university, and then 3 to 4 to 5 years from here, what we learn from drying industry is that high temperature heat pumps are applicable only typically to continuous systems, which also means that one can expect an additional cut in energy consumption in the years to come. And of course, we're thinking about this now already upfront, because we are doing this already in our drying technologies to make sure that we build our machines in such a way that they can be compatible once those high temperature heat pumps will be available up to, let's say, 200 degrees Celsius. So this mainly means that continuous systems are a very good platform to build further on, from a data smart perspective, but also for further energy consumption optimizations. Voila, that's what I wanted to explain. And then I give back the word to Paul. Thanks for your attention already.
Thank you very much, Gert. Thank you to both of you for those sort of presentations. They certainly elicited a few questions in the chat. And as I said, we've also got quite a few that came in beforehand. So we'll sort of try and mix and match the two. I mean, I think, from the UK point of view, obviously there's been a lot more interest in electrification over the last 2 or 3 years. not least because of the cost of living and the reasons for that, and the fluctuations, significant fluctuations in sort of energy price. That there are one or two, I think, sort of challenges that may be specific to the UK in terms of sort of regulations, but we'll sort of put those to one side for today. I think just looking at the questions, there are obviously one or two people have sort of interested in understanding how electricity supply can cope with roasting at scale. And I think you've talked about it probably more from the sort of the continuous sort of flow point of view. But I guess for both that and for batch, what are the thoughts that either of you have to start with on the ability for electric as a sort of a power source or a fuel source to actually cope with roasting at those sort of bigger scales? So if you're looking at sort of an equivalent to sort of the Sherpa machine, just thinking about the ability to get sufficient electricity in and or sort of store. And I think at the same time, just to picking up on that, obviously we've got in the UK the ability to source green electricity, so electricity from renewable sources, but there's also the ability to do that to some extent from gas as well. So whether you have any thoughts as to the sort of the cost differentials that sort of might apply on that sort of green gas versus sort of green energy sort of template, as it were. So any sort of thoughts on those two to start us off? Maybe Gert, do you want to kick off with that?
Okay. Yeah. Yeah, on the differential, I think this is a very true point. I think the differential between gas and electricity is quite high in the UK, typically a factor 4 to 5, while in most of European countries on average we have around 3, except for Scandinavia, which has a spread of 1, which means that gas is not cheaper than electricity. So what we aimed at when we designed the technology was at the most radical improvement possible, to make sure that the price differential, which is always a handicap between gas and electricity today, can be helped between brackets as much as possible. And today we are, compared to the, let's say, the more traditional drum roasters, we are at that factor 2.5 to 3, which already helps a lot. Let's say on average in Europe, this helps on the differential. In UK, it will be still more expensive to use electricity. On the other hand, if you want to move away from fossil fuel, for which food industry on average is one of the first to do so, because we have relatively low temperatures compared to, for instance, chemical industry or construction materials. In fact, there are little alternatives if you want to move away. And some would suggest, and that's probably also a topic in the questions, green hydrogen. But green hydrogen, if you compare it to electricity, will be much more expensive than green electricity, and on the other hand will be the prime source to decarbonize, for instance, a process like chemical process like fertilizer, where you will use them as a building block. So if you want to move away from fossil fuel, then there is nobody with a scientific background that wouldn't say that electricity is the way to go. So also talking to most of the large roasters worldwide, in fact, green hydrogen is the only alternative. It's not taken seriously. Why? Expensive, and it will not be available in the next 10 years, and it should be available for other processes.
Ben, do you want to pick up on either of those points? And probably also from the sort of the batch versus the continuous.
Yeah, no, happy to. Well, as much as I know. So, well, first of all, the Bellwether roaster the shop roaster is single phase, 5 kilowatt. It's roasting small batches each time, and so the power requirements are small, easy, right? It's the same as putting a domestic oven into a cafe retail space. It's not much, and most can do it easily. As it scales, if you need more roasters for larger volumes, then you're typically putting them into bigger sites that are appropriate to the volume of coffee that needs to be produced for that site or for that business. So they tend to get bigger or more industrial, so the power supply into that location will get bigger with it. Because you're right, of course, if you have multiple units, with a larger power draw, you'll need a bigger supply, but that's typical of the bigger buildings. And in terms of cost differential, I mean, yeah, it's the Bellwether roaster costs about or draws about 0.4 of a kilowatt hour per kilo of roasted coffee. Yeah, I mean, we've done analysis into like what the cost of gas is, but if it's it's effectively 10 pence. If it's 25 pence per kilowatt hour cost for electricity, it would be about 10 pence per kilo of roasted coffee. So I saw that in the questions in the chat. I don't know if that answers your question, Paul, but that's my sense of it. Is it's appropriate to the size of the business, and then there's savings to be made elsewhere. Yeah, versus buying wholesale, change in business model.
Yeah, I guess for one or two people, I'm guessing that the sort of the thinking behind their sort of question was, particularly as you sort of scale up on the sort of the batch size, are there going to be, and it's maybe unfair to both of you, it's probably a quite a specific UK question, but are there sort of going to be infrastructure issues in terms of the sort of the electricity supply, generation and supply that causes problems with you actually, being able to sort of draw down sufficient electricity to do what you want to do at those sort of higher levels? I don't know whether either of you have any sort of thoughts on whether you've looked at that, maybe from sort of other countries, if not from the UK.
Yeah, from an industrial perspective, where the supplies are much bigger, of course, we see, for instance, that in the Netherlands, this is quite realistically an issue at the point, because the grid at point is already close to its maximum or close to the maximum that can be promised to customers. But if I would compare this, for instance, for the UK, we're working a lot on malt drying also for beer as well as whiskey. And malt dryers, kilns, typically draw 20 times more electricity if they're electrified than the largest coffee roasters. Why? Because much more water needs to be put out, and the volumes are also much larger, because 4 tons an hour is industrially not that much. It's quite small if you compare it, for instance, to a dryer. So I would say, if I talk to the UK malters, that today they're also on that path of electrification, and they also do those studies which they share with us, and they say, okay, for kilning on the largest scale, which is 20 times larger than roasting, they see the opportunities there. Of course, if everybody does this, and if all industries at the same time will be doing this, this is maybe another question, but for them today, we don't get that warning signal. It will not be possible due to the connection.
Okay, well, that's useful. I think that's something that we may need to sort of just go away and talk to those who understand the UK situation a little better from the supply point, see if we would have the same issue here. There's a couple of questions in here which are sort of quite technical, but certainly of interest to me and some of the things that we've been doing. A question on whether roasting has any impact on acrylamide development, and I guess alongside that furan development, because the two are linked to some extent, versus traditional roasting. So I think this is looking at sort of temperature, time, and some of the challenges that anybody roasting has to be aware of in terms of some of the compounds, etc., that are being developed and released during that roasting.
What I can share around that topic is that in the tests we did, up till now, we didn't see a significant difference. And this is also not surprising, because this is how we built the technology, in such a way that the bean doesn't feel the difference between brackets. However, we haven't stress tested everything up to its limits already, and that's something that we are doing next 6-12 months, also together with the university, because we get the suggestion that it might be even a better result than in traditional roasters, but we cannot prove this yet. But in the test we didn't see a significant difference, and everything was well below the limits.
Yeah, and I will confess that I'm not aware of specific tests on this. It doesn't mean that they don't exist. I would just need to ask our engineering team in the US to understand it specifically on that topic. I couldn't see why logically roasting with electric versus gas would affect that development. But yeah, I don't want to be misquoted on that. So I think that's probably one to go away and get a more definitive answer on that specific answer.
Thanks. Yeah, I would probably agree with you, but I think it just needs the evidence to sort of confirm that. And just picking up on that, because there was another question that referenced back to acrylamide on the maximum roast time that you can roast to in terms of residence time for a continuous roaster. I don't know, Gert, whether you can pick that up, and also at the same time, probably just whether somebody missed it, just mention again your largest size that you have in terms of green coffee kilograms per hour from the Sherpa. Just if you just sort of quote the figures again for that one.
Yeah. So what I quoted was 4 tons per hour, and on the longest roasting time, this is in fact, I would say, unlimited, because the technology has no limits there. On the shortest roasting time, we're still finding the limits, but we see that typically roasting times in a continuous system for similar recipes are significantly shorter for same quality and for same chemical reactions inside the bean. And why is this? Because the fact that we don't lose time between brackets to warm up the batch in the beginning. So the first part of the curve where you typically see the drop, this is not due to the bean, but it's due to the batch. And that part, of course, in a continuous system, for instance, if you have 4,000 kilograms per hour, this means only 1 kilogram per second, which means that you can go up quite fast without impacting in the first phase the quality negatively. So from length perspective, the longer you want, for instance, 20 minutes. Sometimes we roast 20 minutes for our own recipes, and then the shortest will be this. We have to stress that still. We have already tested up to 4 to 5 minutes, and it will probably be even shorter depending on the type of product you want to make with it. Voila. So that's the range that we know today, and it will probably be, and that also means that the theoretical capacity you can do with the roaster can be also larger if the roasting times are even shorter, and depending on the product that you make with it.
Yeah, and in terms of capacity for the Bellwether, it's different, of course, to Gert's roaster, but it's 1.5 kilo batch capacity, takes around 20 minutes for a preheat, roasting and cooling phase for that full cycle. And with our continuous roasting, that's 20 kilos in, about 17 kilos out, take around 4.5 hours if it was just running automatically continuously. So it's, for a working day, it's around 34 kilos a day. And then it scales by duplicating roasters, multiple roasters. So it gives that flexibility to pitch the capacity at the capacity that's required for the business, and to scale it over time, meeting that capacity. So for a small site, 1 roaster will be plenty and can still run a retail and wholesale business on that. For a larger roasting operation, and we have some who are installing 5+ machines into a single site, where they can then use 1 roaster for each coffee and vary the profiles that they're using. So it's more about flexibility and matching capacity to the needs of the business at the time.
Okay, thank you. And probably staying with you, Ben, there's a couple of questions here around sort of cleaning stroke sort of filters.
Yeah, quite specific
changing
ones.
the filters, and then the sort of the later one about thermal cleans or manual cleans, which may be more applicable to you, and the reference to catalytic filters. So whether you can sort of pick up a sort of response to those 2 queries.
Yeah, I can answer quickly on the filters. So they are replaced. They can be replaced by the user. They're sort of clipped in, clipped out, and when we supply them, it depends on the roast profiles being used. So medium roasts would be about every 750 roasts, requires a change of filter, costs around £250. So you've got a sort of maintenance cost, if you like, preventive maintenance cost of about 25 pence per kilo of roasted coffee. I think that answered the question. The other was on consumption per kilowatt. That's the kilowatts per kilo of roasted coffee, but answered that sort of before.
No, I didn't get if you can drop to the later question about cleaning thermal.
Oh, cleaning. Yeah, it's cleaned at that preventive maintenance service point. So every 750 roasts is a manual clean of the window to see the coffee, and that's all. It's a sealed system, closed loop system. So by changing the filters and I think one of the fans in the back, but it's a hour-long service process and simple enough for somebody to do themselves.
And Gert, from your point of view, in terms of cleaning, whether the question about safety of operators may be slightly more applicable in terms of the size of machines, some of the bigger machines in your range.
Yeah, that's also one of the reasons why we'd rather build larger machines than smaller ones. For our type of technology, smaller is more difficult than larger. Let's say because the accessibility is much easier. If you look at if I compare our pilot one to the one that we operate ourselves right now, it's like enormously more easy to clean. And indeed, depending on the model, we foresee either manual preventive cleaning cycles. At first, at the root, we made sure that the deskinning happens after the roasting, because this would be a huge source of pollution. So that's at the source, and then you have, of course, preventive maintenance. And for the larger models, we're also looking into automatic cleaning. Yeah.
Okay, thanks. There are a couple of questions just going back to this issue of green gas and green electricity. And I think, Ben, you talked about some of the CO2 sort of savings as a percentage earlier on. But there was a question, I think, where you're looking at the sort of supply of a sort of a greener gas. Do you have any sort of figures as to how that carbon saving percentage might sort of change? I mean, we obviously getting sort of slightly closer, but do you any feel of the sort of the magnitude of any carbon saving difference?
Yeah, well, I have to confess, these calculations I've got of kind of 87% versus a centralized gas roaster would be based on the US energy mix. So just taking from the regular US energy mix. So we haven't factored into there what would it be if you were buying renewable energy or even generating renewable energy yourself, but it would be radically less because most of the energy is in the electric that you're using as opposed to using gas. So I'd only see an upside from that if you were purchasing or generating renewable energy. And then, of course, it just depends on the supply you're getting and the cost you're paying for green energy. Or even better, if you're in a site where you can generate your own, brilliant, then that will only be much better. But I have to say, I don't have those numbers for the cost of green energy in the UK or how that would change as you generate your own.
Any thoughts from you, Gert, looking at it from a sort of a European point of view?
Well, let's say on CO2, you can make the calculations based on the energy mix, but our focus has always been first make sure that you don't use electricity or energy to cool where you don't need it. So first focus is on energy consumption, and then secondly, how much you save. For instance, if you look at Scandinavia or Canada, where almost all grid-connected electricity is green, we often see that customers are also co-investing in, for instance, a windmill or in solar panels, which is, of course, very interesting from perspective of renewable, but also from a cost perspective in the long run. The question we often get, because our roaster is so hyper efficient, is can you also connect it or fuel it with gas, which would be not an illogical option from a broader perspective. But there we made the choice as a company. You could compare it a bit to Tesla, where you would ask, do you also have a diesel one? We made the choice not to make hybrid technology, although you also save gas and fossil fuel with that. We have chosen as CE that it's, and Ray Jules, that it's our role to pioneer. So our roasters will only be available as electric roasters. Although the other argument is also a valid one, but we made the choice to be the front runner, and then probably the large competitors will have a kind of hybrid approach, which is logic from their perspective. From our side, we have chosen to go all electric. Voila. And then how the electric is generated, that depends on the region, on the customer itself. That's something that at this point we don't offer alongside with our projects.
Ben, probably one more for you, I guess. Somebody had raised the question about the use of solar energy, which I guess would be probably more applicable in terms of the smaller sort of equipment. Do you have any customers that are using sort of solar and particularly solar via battery storage? And if so, do you have any sort of figures around the sort of the environmental gain when you're factoring in the sort of the battery production as well? Again, just trying to think about it from a carbon balance point of view.
Yeah, well, we don't. We're still yet to have we have installations in central London at the moment, but only 2 of them, and the rest of the roasters are coming later this year. So I do know some of the sites that we're going into have intention to run at least some, generate some solar power themselves. I think the best example I've got, James Hoffman did a video with us last year where he did an experiment roasting in the desert, and it was using a mobile solar panel with batteries to roast, and does a good job of breaking down the energy consumption and and what's required. That was on our Series 2 roaster. So there's a good video, good fun to watch on YouTube, and a good place to go for it. But yeah, I think that's, I don't have those case studies here in the UK yet, because we're just getting started, and the roasters will be installed later this year. But again, in terms of impact on the emissions and the cost savings, I guess it's going to be down to the site and how much of that energy is generated on site versus purchased from the grid. But like I said, I think that principle of versus gas starts with our number of kind of 87%, and I think it's only going to improve on that if you're generating yourself.
And whether either of you have just seen, Andy has just dropped a point in the chat. I think that's the last sort of bottom point on the chat. The challenge in the UK is that we can buy green gas, so it has no carbon emission associated with it. Therefore, the investment from an electric roasting point of view has to be justified only on the financial benefit basis. Whether either of you have any sort of thoughts on that? So it's relating back to this sort of green gas point that we made just earlier.
Yeah, sure. Well, I mean, similar to Gert, we won't ever make a gas roaster. We're an electric roaster, and it's been designed like that from the bottom up, and that's what we believe in. So otherwise, financial benefit, yeah, absolutely. I mean, compare it to the cost of a Bellwether to an equivalent size or kind of capacity in a gas roaster, and the purchase cost, the installation cost, and the places in which you can install it will stack up easily. So I sort of feel confident in the financial justification, operating costs, maintenance, installation, and then the flexibility that you have as to where to put it.
Any thoughts from you, Gert, on that? There's a couple more coming your way afterwards.
Well, my question would be, what is green gas? Question mark. So it's a separate discussion. But what I see, let's say, in other domains where the electricity consumption or where the energy consumption is much higher, is that you see typically, for instance, biogas as a potential one. For instance, for beer industry, the waste stream, which is then anaerobically fermented, gives back a lot of energy. This is a very good example because it's on site and the waste stream will always be there. But many of what is called today green gas supply is either temporarily until it's used up to that, let's say the waste stream is used up. Either fertile grounds for food consumption are used to make biofuel or biogas, and then our question would be, in the long run, we don't believe this to be a sustainable solution also. So question would be, but this is, I think, a totally different discussion or a separate topic, I would say, is that what is green gas? Something that it's like a transitionary measure. How will you scale this if everybody uses those sources? And we are not convinced that that will supply more than 5 to 10% of the total consumption. So then the question is it a temporary measure like green hydrogen is pitched right now or not? We have the feeling it does. But of course, you can have fundamental and even ideological discussions about that, I've felt.
Okay, I'm conscious we've got only a couple of minutes sort of left. We've got a couple of questions in here. Actually, you've got a reference. I'll leave that reference that Thomas has just put in. We can sort of read that. I think it's coming back on Andy's earlier point. But Gert, a couple of last questions for you, both from Debbie. One in terms of the transition from one recipe to another and material losses, and how do you manage those material losses versus what you would see from a batch roaster, and then if you want to make any comment on the other one in terms of the existing electric roasters on the market, and how you sort of compare to those two. A little bit of a marketing plug at the end.
Yeah, in terms of material loss, it's a topic that we can discuss also more technically for the interested people, but we have algorithms in place that make sure that the beginning and the end of the curve are not influenced by the fact the beans that are on the beginning and at the end. So, which means that, for instance, for Ray and Jules, we haven't thrown away a bean since the last 5 years. And so we never threw, so there is zero loss based on the fact that you change over. We also build a system in such a way that the changeovers are quicker than in a traditional system. So we typically also get up higher OEEs than in traditional systems. So this can also be helpful, because this is a difference with traditional electrical roasters, where you typically see that they're much more unstable in terms of quality, because the roasting times are very difficult to steer upon, and on the other hand side are very difficult if you change recipes. Well, we took it the other way around. We want to change fast, which also means that the runs, for instance, we do as a specialty roaster as Ray and Jules, are very short runs, so we change all the time, but we plan in such a way that the changeover times are significantly shorter than in a traditional drum system, for instance. Voila. But from a loss perspective, there I can be quite clear. We make sure that we adapt automatically the beginning and the end of the curve, so there are zero losses.
Okay. Conscious again, as I say, of time, so I think we'll call a halt there. I think both Ben and Gert are more than happy to sort of receive queries from you if you want to sort of get in touch with them afterwards. I don't think we've got emails down there, but we can probably provide your respective sort of email addresses to people. As Thomas has just put on the chat, and I mentioned at the start, I think a recording of this, once Thomas has just edited a few of the ums and ahs out, will go onto the website at that link that you can see probably in the next sort of 2 or 3 days, so at the beginning of next week, hopefully, and all of the other webinars that we've run, the public ones, are on there as well that you can peruse. And I think we do get quite a number of people that will go back and have a look at them again. So can I thank both of you for what's turned out to be a really great sort of presentation, a lot of information, and also thank the audience, because we've had an awful lot of questions both on the day and sort of beforehand, which has taken us right bang up to time. So I think an interesting subject, I think one that a lot of people are looking at sort of very closely in terms of, will this work for us? How can we make it work for us? And particularly looking forward in terms of the wider sustainability requirements that all businesses are continuing to sort of look at. So thank you very much. Thank you to the audience. I'll say, as I always do, if you've got any topics that you would like us to sort of pick webinars on, then please let us know. We're putting together a range of different ones, but we're always happy to sort of welcome suggestions from you as well. Yeah, both Gert and Ben have just dropped their emails into the chat. So with that, thanks again to both of you. Thanks to Thomas for helping set up all this up and running it. And thanks to you all for your contributions. Have a great rest of the day and a great end of the week. Thanks all. Cheers. Bye-bye.
Thank you.